Now in this circuit, what we can see is we have one resistor and we have one another resistor, and this is 3 ohm, this is 5 ohm. We have one capacitor here and another capacitor here, and all these four components are connected in series. We have one RC branch here and we have another RC branch here, and they are also connected in series. Now the value of those capacitors are given in different form. The value of this capacitor is written as minus J for ohm. That means this is the value of the capacitive reactance, since the unit is ohm, and that is also represented as minus J4. So this 4 is the measurement of 1 by omega C, and the value which is written against this second capacitor is 200 microfarad. That means this is the straightforward the value of the capacitor, capacitance of that capacitor. Now this branch, this RC branch is energized by an AC sinusoidal voltage which has the value 220 volt, and the frequency of that supply is 50 hertz. Now this 220 volt is not the instantaneous value, rather it is the measurement of RMS value, because we know in case of AC circuit the value that which is represented, that value, that constant value is the measurement of RMS value. So if it is voltage, then RMS voltage; if it is current, then RMS current. Now these are the four things that we have to calculate from this circuit. So first we have to calculate the total impedance of this circuit. So total impedance Z we can find this way, that Z will be, since this R and C, both the resistors and capacitors are connected in series, so it can be written as, for the first RC branch, the impedance will be R1 minus JXC, or we can represent this way XC1. This is for the first RC branch. Then for the second RC branch, we can write R2 minus JXC2, and since they are connected in series, so we can simply add them to get the final impedance. Now this R1 and R2 we can simply separately add them since they have the real values, and we can separate the imaginary parts. So it will be minus J and then XC1 plus XC2, and R1 and R2 they are having the values 3 and 5 ohm respectively. So 3 plus 5 and minus JXC1 already have value as 4. So the minus sign was already was taken into consideration here, and so I'm writing here only the magnitude, which is 4. Now for the second capacitor, the value of the reactance is not written here, rather the capacitance value is given, but we can still find out. We know that XC2 will be, value wise it will be 1 by omega C2. Omega is the value, is the measurement of 2 pi f, where f is the supply frequency or linear frequency of the supply. So 2 pi small f, and 2 pi small f value is 50 hertz. That means finally it will be in the denominator, it will be 314, and then the value of the capacitance is 200 microfarad, so it will be 200 10 to the power minus 6, and finally when we calculate this value we will get as 15.92, and since this is the value of the reactance, so it will be ohm. So that means in place of this reactance value we can write 15.92, and finally it will be 8 minus J 19.92 ohm. So this is the measurement of the impedance of this whole circuit. Now this impedance value can be obtained in some other way. Now Z, we know that it will be, Z is the impedance of that path, so it can be written as R minus JXC. C is the C equivalent. Now here the R is the equivalent resistance of this path. So here R will be simply represent the resistances, so it will be summation of both the resistance values R1 plus R2, and it will be J XC2 in place of XC. We can write omega 1 by omega C, and this will be this C will be the equivalent capacitance of these two capacitances. So R1 plus R2, again it will be 8, then minus J, and 1 by omega. Since these two resistances are in series, so we know in case of capacitance, when the two capacitances are connected in series, we follow this relationship. So it will be 1 by C equivalent will be equal to 1 by C1 plus 1 by C2. That means C equivalent can be found this way: C1 C2 divided by C1 plus C2. So in place of this equivalent capacitance, we can write this expression C1 C2 divided by C1 plus C2. So here we can write 8 minus J, and this C1 plus C2 will go up, means it will come in the numerator, and they are having the values. The first one, again, for the first one we don't know the capacitance value, but we can still find xc1 again will be 1 by omega C1. So C1 will be 1 divided by omega xc1, and it will be, omega is 2 pi f, so again it will be 314, and xc1 has value 4. So finally this value of the capacitance will be 796 microfarad. So this way we can find out the value of the capacitance, and which we can put here. So C1, in place of C1 we will be writing 796, and in place of C2 we will be writing 200, and divided by 796 plus 200, which will be 996. And since we are adding these two values which is in microfarad, so here we will have term 10 to the power minus 6, and again we are dividing these two values which separately is in microfarad, so here we will have 10 to the power minus 12. So in the numerator 10 to the power minus 12, since we are multiplying 10 to the power minus 6, two terms, 2 10 to the power minus 6 we are multiplying, so in the numerator we will have 10 to the power minus 12, in the denominator 10 to the power minus 6. So finally in the numerator we will have 10 to the power minus 6 this term, and if we simplify further, then it will have this value as 8 minus J, then 1 divided by 0.050189, and finally it will be 8 minus J, 19.92. Maybe it is taking long, but I have explained both the ways to find the value of the impedance. So either way we can find out. Now the second question is to find or to obtain the power factor angle. For this we know the formula, and the power factor angle means the phase difference between voltage and corresponding current. So it will be simply tan inverse, we know, 1 by omega CR. If it is simply in that circuit, if we have one capacitor and one resistor, but here we have two branches, two RC branches, so simply it will be the reactance value means XC divided by the resistance value C equivalent, and then resistance value. Now here in place of XC equivalent, it will be simply XC1 plus XC2 and divided by R1 plus R2. So it will be tan inverse, then the reactance of this XC1 of the first capacitor will be that has a value 4, and for the second capacitor the reactance value we have already found, that is 15.92, and the resistance values are given, that is 5 plus 3, which is 8. So it will be tan inverse, it is 19.92 divided by 8, and if we calculate further, then tan inverse this value will be 68.12 degree. That means the phase angle or the phase difference between voltage and current of this whole branch will be 68.12 degree. Now the third parameter that we need to find is the RMS value of the total current which flows in this series circuit. Now the IRMS, we know that can be easily found by this relationship Vrms divided by the impedance of the whole circuit. Now Vrms we can get from the given data. It is given as 220 volt in the problem statement. So V, in place of Vrms we can write 220 and divided by the Z value or impedance value which we have already calculated in the first step, which is 8 minus j 19.92. So in place of Z it will be 8 minus j 19.92. Now this we are dividing here 220 divided by a value which is represented in rectangular format. Now to do this division faster way, what we can do, we can use calculator, and first we can convert this rectangular value or rectangular format into its corresponding polar format, and then we can divide easily. Now since it is given only the real value is given, so if we want to represent this in rectangular format, then that can be represented this way, or else if we want to represent this value in polar format, then that can be written or that can be represented this way, 220 then angle 0 degree. Or if you don't want to use calculator, or if you don't have a calculator ready, then what we can do, we can use the formula that I have already shown you in one of my previous lectures, that will be 220, then here it will have 0 degree, and then we can, and in this lecture itself also we have seen this formula, so it will be h square then 19.92 square. So this will be the value of the r, and then here the angle value will be tan inverse 19.92, or rather it will be minus 19 because here we have the negative sign. This is capacitive circuit and divided by 8. Now from here we will get 220 0 degree, and in the denominator this will give us a value which will be 21.4664, and the angle value we have already found in our previous step, and that was tan inverse this value gave us a value 68.12. so here we have negative signs, so in the denominator we will have minus 68.12, and 220 divided by 21 point this value finally will give us a value 10.25, and angle wise they will be simply subtracted. So 0 degree minus of minus 68.12, so finally it will be 0 plus 68.12, so 61.12 degree, and this is the measurement of current, so it will be ampere. And we have already seen that the current always leads its corresponding voltage in case of capacitive circuit. So since this is not a purely capacitive circuit, that's why it is 68.12, which is less than 90 degree. Now the next parameter that we have to find out is the expression of the instantaneous current. Now we have already seen the format is I will be equal to now peak value, which is Im, then sine omega t, but since voltage was taken as a reference, so it will be sine omega t, and the phase angle, phase difference, since current leads voltage, so it will be plus theta. So here the peak value of current will be RMS value multiplied by root 2, and then sine omega t, and then theta value is 68.12 degree that we have just calculated, and IRMS value also it is 10.25. So 10.25 when it will be multiplied by root 2, then it will give us a value which is 14.5. Here we will not take the, or will not consider the angle part, because we within this sine term we are incorporating that phase angle or phase difference, so we will not consider here the angle separately, that I have also said earlier. And since this is the expression of current, so it will be ampere. In my next class I will discuss about series RLC circuit. Thank you.